Hey everyone, I thought I'd do a little follow-up from the circuits assignment from yesterday. So I have the circuit already built, and if you haven't figured it out yet, you can actually change these values, okay, to make sure they match what is given in the assignment. So first question, it says if the light bulb 1 burns out, what happens? So if light bulb 1 burns out, that means the little filament inside it breaks. Okay, so it's kind of the same thing as removing it, and we can see that nothing will work in this circuit if light bulb 1 breaks. All right, what about light bulb 2? Same idea, so if we have a break right here, everything's going to stop, okay? What about light bulb 3? Rid of that one. So if light bulb 3 burns out, that means 4 stops working because the electrons can't get to it, but 1, 2, and 5 will continue to function. All right, and if 5 burns out, then this side will go out and these 4 will continue to function because there is still a path for the electrons to be able to get through. All right, now it's asking you to measure some different things at different points on the circuit. So this is an ammeter right here, okay? That's what this A stands for. Some people were asking what the A stands for. That's your ammeter. So what kind of reading would you get? Well, if you're going to get 4 amps here, you're still going to get 4 amps here, okay? It's going to lose voltage, but the current is going to stay the same. So it's 4 amps at the top and still 4 amps here before it splits. Now, what happens at the split? Well, in this case, it's splitting evenly. That doesn't necessarily have to happen. But because it so happens that these two light bulbs together make 12 volts and this one on its own makes 12 volts, that makes things work evenly and the current is going to split. So if you think about it, for every 4 electrons coming along here, 2 are going to go this way and 2 are going to go this way. They're going to alternate. 1, 1, 1, 1. All right, so those are 2. And then when they meet back up again, we're back to 4. Okay, so that's the current for the circuit. Calculate the total voltage supplied across, supplied to the circuit. So that's your battery. So how much total voltage? Well, if you think about it, an electron comes along down here. It goes through the first battery, gets 12 volts. Okay, well, these are backwards, that's why it's reading negative. And then it goes through the second one, and it's going to add 9 more volts. So 12 plus 9 is 21. Add another one, we get another 9 volts, that's 30. Add the final 6, and we get a total of 36 volts added to the electrons. So they come along, they're going to drop some off here, which I believe is 12 volts. I think it tells us that right here. Okay, so it drops off 12 here and 12 here. So if it drops off 24, that leaves 12 to go through each direction this way. And that's how we know that this light bulb's at 12 volts. All right, calculate the resistance of light bulb. I think I just put 1 in your assignment. They're exactly the same. So we know that the voltage is 12 because it says that in the diagram. And the resistance is what we're calculating. And the current in that section is 4. Not sure why I can't get this to read the voltage. Oh, I'm not getting on each side of the light bulb. That would be why. There we go. So the negative is just direction. It's going backwards through the machine. All right, so current is 4, voltage is 12, V equals I times R, so R equals V over I. 12 divided by 4 is 3 ohms. All right, same thing for light bulb 2. Then it asks you to calculate the resistance of light bulb 3 or 4. Okay, so the voltage this time is 6, and the current in this box was 2. We measured that, if you remember. So 6 divided by 2 is 3 ohms. And lastly, we're asked to calculate the voltage drop across light bulb 5. A couple ways we can do that. We could do Ohm's law. So we know the current is 2, and we know the resistance is 6, and 6 times 2 is 12. V equals I times R. So 6 times 2 is 12, so it's 12 volts. And the other way, as I showed you, we can talk about the electrons come along with 36 volts, drop off 12 here. They drop off 12 there, so they dropped off 24. That leaves 12 left. They have to be 0 when they get back to the batteries. Okay? It says calculate, so I was thinking Ohm's law, but there really is 2 ways you can do that. Okay, so I hope that helps explain all the different principles we've learned so far. With our parallel circuit here, series here, batteries are in series. Ohm's law, you did have to put a lot of stuff together. All right, have a super day. Thanks for listening.